Hello students, welcome to the second part of our PYQ discussion series on single variable differential calculus. In this part, we'll solve related PYQs from JAM economics paper in detail. Please like, share and subscribe to our YouTube channel if you find it helpful. Thank you for joining. Let us start discussing the solutions. Okay, so let us start solving the PYQs. The first question is from 2024 and it says that limit x tends to infinity 1 plus 1 upon x whole to the power x is equal to which of the following. Now we know this is a very standard limit and इसका value होगा e. So इसके लिए हमारा correct option is A. Let us move to the next sum. It is from 2023. Here you have been given one sequence an is equal to 1 plus 1 upon n whole to the power n by 2, and you have been asked to say which one of the following is not correct, कौन सा wrong है. First option is an is bounded, second is n is increasing, third is summation log an is convergent series, and fourth one is limit n tends to infinity 1 upon n summation k running from 1 to n is under root e. So what we'll do first, we'll try to calculate the limit of this sequence. पहले हम इस sequence का limit ढूंढने का कोशिश करेंगे. तो देखिए, it is a well known fact that limit n tends to infinity 1 plus 1 upon n whole to the power n is e. ये एक well known fact है. So limit n tends to infinity an, ये क्या हो जाएगा, limit n tends to infinity 1 plus 1 upon n by 2, and we can take that 1 by 2 outside as follows. We'll write limit n tends to infinity 1 plus 1 by n whole to the power n, and that half will come out. So it will be e to the power half or under root e. So definitely this is a convergent sequence. So an is convergent, and we know that every convergent sequence is bounded. So option A is correct. Now इसी के साथ हम बता सकते हैं कि ऑप्शन डी भी करेक्ट है. क्यों? कॉचीज फर्स्ट लिमिट थ्योरम से हमें यह पता है इफ एन इज अ सीक्वेंस और उसका लिमिट अगर एल है, तो जब आप सीक्वेंस ऑफ एरिथमेटिक मीन ले रहे हैं, मतलब सीक्वेंस का nth टर्म होगा 1 by n समेशन ए के रनिंग फ्रॉम 1 to n, ऐसा सीक्वेंस का लिमिट भी एल ही होगा. मतलब सीक्वेंस का इस सीक्वेंस का लिमिट चेंज नहीं होगा. तो यहाँ पे एन का लिमिट था अंडर रूट ई. सो डेफिनेटली लिमिट n tends to infinity 1 by n समेशन ए के रनिंग फ्रॉम 1 to n, इसका लिमिट भी अंडर रूट ई ही होगा. सो ए एंड डी आर करेक्ट. अब आते हैं बी पे. बी के लिए हमें चेक करना है एन इंक्रीजिंग है या नहीं. सो हम कैसे चेक करेंगे? इसके लिए हम डिफरेंशिएशन का थोड़ा हेल्प लेंगे. अब देखिए, आपके पास यहाँ पे सीक्वेंस है ए एन इज इक्वल टू 1 प्लस 1 अपॉन n whole to the power n by 2. What we'll do first, we'll first convert it to a function for positive real numbers. Positive real numbers के लिए एक function में ये convert कर लेंगे. कैसे करेंगे? I'll just replace n with x. And if you do this, the expression will become 1 plus 1 upon x whole to the power x by 2. ये एक फंक्शन बन जाएगा. अब ये फंक्शन को हम कंसीडर करेंगे x greater than 0 के लिए. Now let us do one thing. Let us differentiate the function. The first derivative of the function will become x by 2 1 plus 1 upon x whole to the power x by 2 minus 1. Now you note carefully, आपका x का वैल्यू जब 0 से बड़ा है तो ये वाला जो पार्ट है x by 2 ये 0 से बड़ा हो जाएगा. 1 plus 1 by x 0 से बड़ा हो जाएगा. इसके लिए इसके ये पावर भी 0 से बड़ा हो जाएगा. So that means this entire value of f dash x will be bigger than 0 whenever x is bigger than 0. और f dash x का वैल्यू किसी भी इंटरवल में 0 से बड़ा है, that essentially means that f increases in that interval. So that essentially means f x increases as x increases. x का वैल्यू जितना बढ़ेगा उतना ही fx का वैल्यू भी बढ़ेगा. So definitely n का वैल्यू अगर बढ़ेगा fn का वैल्यू भी बढ़ेगा. So just get back to the form of n. So as in n increases, fn will increase. So definitely अब fn है क्या? fn तो actually है आपका an. So an increases as n increases. So that means an will be increasing. So far we have proved that A, B and D are correct. The next option is summation log an is a convergent series. हमें चेक करना है whether summation log an एक convergent series है या नहीं. So this one will be false. How will you show this? We'll just recall a very small fact. अगर किसी भी सीरीज कन्वर्जेंट है तो उसका nth टर्म will tend to 0. ये रिजल्ट हम पिछले वीडियो में डिस्कस कर चुके हैं, बट स्टिल आई एम वंस अगेन रिमाइंडिंग यू. आप किसी भी सीरीज an को ले लीजिए, इफ इट इज समेशन an को ले लीजिए, इफ समेशन an इज कन्वर्जेंट देन लिमिट an will tend to 0. Now what is the given series here? It is summation log of an. Log of an means n plus 1 plus 1 upon n whole to the power n. Okay, so this is the series, and we'll show that for this series this result will fail. That means we'll show that limit n tends to infinity log 1 plus 1 upon n whole to the power n is not is equal to 0. ये हम शो करेंगे. तो कैसे शो करेंगे? इसके लिए हम हेल्प लेंगे एल'हॉपिटल रूल का. फर्स्ट ऑफ ऑल, to calculate the limit, we'll first convert it to a function for positive real numbers. So we'll just convert things to x. So we'll just replace n with x. So that will have the same limit. If limit exists, that will have the same limit as x tends to infinity log of 1 plus 1 upon x whole to the power x. So taking, I'm sorry, this will be n by 2, n by 2, x by 2. Okay, so now bringing x by 2 in the front, we'll be having it ln of 1 plus 1 upon x. So that means half will come out. We'll be getting limit x tends to infinity, and here I'm getting log of 1 plus 1 upon x equal to the power 1 by x. So now if you are, as you are tending x to infinity, this part is tending to 0. So this entire thing will tend to log of 1, that means 0. And once again, as x tends to infinity, this part will tend to 0. So this is of the form 0 upon 0. So this is 0 by 0 form. So this is 0 by 0 form. So using the L'Hopital rule, we'll differentiate both numerator and denominator. So we'll be having 1 plus 1 upon x in the denominator, and above it will be minus 1 by x square. That will be obtained by differentiating the numerator, and by differentiating the denominator we'll be having minus 1 upon x square. So that part will get cancelled. So we'll be having 1 in the numerator. So ultimately that will turn out to be half times 1 by 1 as x tends to infinity, that means half, which is not is equal to 0. So since limit of the nth term is half, that means not equal to 0, so the series is not convergent. Series is not convergent. Okay, so correct options are A, B and D. Let us come to the next question. It has been asked in JAM 2021, question number 35 of 2 marks. Here we have been given a function f. Fx is defined in the open interval minus pi by 2 to pi by 2, and it is defined as fx is equal to cos pi by 2 plus mod x upon sin pi by 2 minus mod x. 4 options are given. 1. F is not continuous at x equal to 0. B. It is continuous but not differentiable at 0. Third, limit x tends to 0 plus fx minus f0 by x is minus 1. And fourth, the derivative of f at 0 is minus 1. So let us discuss them one by one. First of all, let us rewrite fx by removing modulus. So fx is actually cos of pi by 2 plus x upon sin pi by 2 minus x when x is greater than 0, because the value of the mod x is x when x is greater than 0 and minus x when it is less equals to 0. So when x is less equals to 0, it will be cos of pi by 2 minus x upon sin of pi by 2 plus x. So this is the expression of fx when we are removing modulus. So let us simplify this a bit. So that means when x is greater than 0, cos of pi by 2 plus x upon cos of sine of pi by 2 minus x. So now cos of pi by 2 plus x is minus sine x upon cos x, and when x is less equals to 0, it is cos of pi by 2 minus x, that means sin x, upon sine of pi by 2 plus x, that means cos x. So sin x by cos x. When it is less equals to 0, x is less equals to 0. That means when x is greater than 0, minus sin x by cos x means tan x, and when x is less is equals to 0, sin x by cos x means, okay, the first one is minus tan x, and now when x is less equals to 0, it is tan x. So that is the expression of fx. Okay, so now you have to check whether it is continuous or not to check the first option. So what will be the right hand limit of fx? As x tends to 0 plus, we'll be using this formula, that means limit x tends to 0 plus minus tan x. So now if you put x equal to 0, you will be getting 0. So this is 0. And if you are trying to calculate limit x tends to 0 minus fx, you have to use the second formula. That means this will turn out to be limit x tends to 0 minus tan x, and putting x equal to 0, it will be 0 as well. So right hand limit and left hand limit are equal. So that is equal to limit of fx x tends to 0 plus. So both the limits are equal, and definitely this is equal to f of 0, because if you put 0 here, you will be getting cos pi by 2 by sine pi by 2. So that means this will be 0. So definitely the limit exists at fx, right hand left hand limit is equal to right hand limit, this left hand limit is equal to right hand limit is equal to the functional value. So f is continuous at 0. So the first option is not true. For the next one, we'll calculate whether f is differentiable or not at x equal to 0. So let us start calculating that. First we'll start calculating the right hand derivative. So right hand derivative at 0 will be limit x tends to 0 plus fx minus f0 by x. So when x is bigger than 0, we'll use this formula. So that will turn out to be limit x tends to 0 plus fx means minus tan x, f0 means 0 by x. So that is limit x tends to 0 plus. So we'll take minus out. This will be tan x by x. So it is of the form 0 by 0. So by using L'Hopital rule, the value of the limit can be obtained by differentiating the numerator and denominator. If you differentiate the numerator, you will be getting 6 square x upon 1, and numerator, if you differentiate the numerator, you will be getting 1. So by putting x equal to 0, you will be getting minus of 1. So that is the value of right hand derivative. And now let us calculate the left hand derivative. So if you calculate the left hand derivative at 0, this will be limit x tends to 0 minus fx minus f0 by x minus 0, that means x. So as x tends to 0 minus, so we'll be using this formula, that means tan x. So that will be limit x tends to 0 minus tan x, f0 is 0 by x, so that is limit x tends to 0 minus tan x by x, once again of the form 0 by 0. So once again we'll be using L'Hopital rule. We'll differentiate the numerator and the denominator, and putting the value x equal to 0, we'll be getting 0. I'm sorry, getting 1. तो हम एक चीज देख सकते हैं कि राइट हैंड डेरिवेटिव का वैल्यू -1 है, लेफ्ट हैंड डेरिवेटिव का वैल्यू 1 है, ये दोनों अनइक्वल है, तो f'0 एग्जिस्ट नहीं करता है, डज नॉट एग्जिस्ट। तो फंक्शन डिफरेंशिएबल नहीं है, so the function is not differentiable is a true statement. F is continuous but not differentiable, so option B is correct. Now what does option C says? It says limit x tends to 0 plus fx minus f0 by x equal to -1. Actually this is the right hand derivative, and we have already calculated that, this one, right hand derivative, and we have found the value to be -1. So the option C is correct. Option D says that f'0 equal to -1, but we have just shown that this limit does not exist, so this is not true. So A, B and C are the correct option for this question. Next question, a similar question from JAM 2022. Here a function f is defined as mod x plus cos of pi by 2 minus x for all values of x inside the open interval minus pi by 2 to pi by 2. 4 options are given. First one, f is continuous on minus pi by 2 0 open interval union 0 pi by 2 open interval. Option B, f is differentiable at x equal to 0. Option C, f is differentiable everywhere except x equal to 0. And option D, limit of fx as x tends to 0 is equal to 0. You have to tell which of the followings are true. So first we will start by simplifying the expression of fx. We first note that this part, cos of pi by 2 minus x, is sin x. So definitely fx will be equal to x plus sin x when x is positive. X is positive means x will be bigger than 0, and noting the domain, x has to be less than pi by 2. Similarly, if x is less than 0, less than or equal to 0, then it will be equal to minus x plus sin x. Definitely x will be bigger than minus pi by 2, noting the domain of the function fx. So this is the simplified expression for fx. So now if you note fx carefully, then you can see one thing, that x is a continuous function, sin x is a continuous function. So definitely x plus sin x is a continuous function. So fx is continuous on 0 to pi by 2 open interval. Similarly, the another expression minus x plus sin x is also continuous on minus pi by 2 to 0. So that means fx is continuous on minus pi by 2 to 0 as well as 0 to pi by 2. So definitely it is continuous on their union. So option A is correct. Before discussing B and C, which involves differentiability, let us solve a easier part, and that is option D. So first of all, note that if you try to calculate the right hand limit x tends to 0 plus fx, definitely for that we are supposed to use the positive value of x, that means this expression. So that means this time the expression of fx will be x plus sin x. So if you put x equal to 0, you will be getting 0. Similarly, if you calculate the left hand limit, you are supposed to use this formula of fx. So that will turn out to be limit x tends to 0 minus x plus sin x. So by putting x equal to 0, we will be getting 0 here. So from last two calculation, we can see that the right hand limit at 0 and left hand limit at 0 are equal, and they are not only equal, they are equal to functional value at that point f0, because once again if you put x equal to 0 here, you can see that you will be getting 0 plus cos of pi by 2 minus 0, so cos of pi by 2, so f of 0 will be 0. So that means right hand limit is equal to left hand limit is equal to functional value at 0. So limit x tends to 0, fx exists and it is equal to 0. Okay, let us now resolve the issues regarding B and C. So for that we can see one thing, that whatever functional expression fx has, they are definitely differentiable. X plus sin x is a differentiable function, and so is it on the open interval 0 to pi by 2, and similarly minus x plus sin x is also a differentiable expression. So this is a differentiable function, fx is a differentiable function from the open interval minus pi by 2 to 0. So one thing is sure, that unless x is 0, it is clearly differentiable. So to check B and C, we just need to check whether it is differentiable at x equal to 0 or not. That's all we have to check. So once again, to solve it, we have to check whether f dash 0 exists. So to understand the value of f dash 0 or its existence, we need to calculate right hand derivative and left hand derivative at 0. So what is the right hand derivative of f at 0? It will be limit x tends to 0 plus fx minus f0 by x. So when x is 0 plus, we must use this expression, so x plus sin x. So limit x tends to 0 plus x plus sin x, f0 is 0 minus 0 by x. So limit x tends to 0 plus. So you can see x plus sin x upon x is of the form 0 by 0, because if you put x to be 0 in this expression, you will be getting 0 in the numerator, and similarly you will be getting 0 in the denominator. So whenever you are getting a 0 by 0 form, we are supposed to use L'Hopital rule. So we'll be differentiating the numerator as well as the denominator. By differentiating the numerator, we'll be getting 1 plus cos x, and by differentiating the denominator, you'll be getting 1. So by putting x equal to 0, we'll be getting cos 0. That means we'll be getting, so this is we'll be getting 1 plus 1 by 1, so that is 2. So that is the right hand derivative at 0. Let us now calculate the left hand derivative. Everything will remain same other than the limit which will tend to 0 minus this time. So limit x tends to 0 minus fx minus f0 by x, and here we'll be using the second expression of fx, that means minus x plus sin x. So that will be limit x tends to 0 minus x plus sin x minus f0 is 0 upon x. Once again it is of the form 0 by 0. So once again we will be using L'Hopital rule, and we will be differentiating the numerator and denominator. By differentiating the numerator, we will be getting minus 1 plus cos x, and by differentiating the denominator, we will be getting 1. So by putting x equal to 0, we will be getting minus 1 plus 1 by 1, so 0. So we can see different value of right hand and left hand derivative. So definitely the function is not differentiable at 0. So the function is differentiable at 0 is a wrong statement. So it will be differentiable everywhere except 0. So C is correct. So for this question number 34 of JAM 2022, the correct options are A, C and D. Okay, so the next question from 2023, it's a numerical answer type question. Here a function fx is given, which is of the form x to the power 4 plus 2x cubed plus kx squared minus k. K is unknown here. If x is equal to 3 by 2 is a point of local minimum of f, and small m is a global minimum value of f, then you have to find the value of f0 minus m. So first we will note one thing, that this local minimum or global minimum, they must occur at a point x where f dash x equal to 0. Now we have fx equal to x4 plus 2x cubed plus kx squared minus k. X equal to 3 by 2 is a point of local minimum, so definitely f dash at that point is 0. Okay, so let us first calculate f dash x. So f dash x equal to 4x cubed plus 6x squared plus 2kx. So if you put the value of 3 by 2, what do you supposed to get? So f dash 3 by 2 is equal to 4 times 3 by 2 cube plus 6 times 3 by 2 square plus 2k into 3 by 2, and it is given that this is 0 since 3 by 2 is a point of local minimum. So let us calculate this. This is 4 into 3 by 2 cube means, it's 27 by 8 plus 6 into 3 by 2 square means 9 upon 4 plus 3k is equal to 0. So that is 2 and cancelling it out, we are getting 3 here, 2 here. So first term is 27 by 2, second term is once again 27 by 2 plus 3k is equal to 0. So that means 3k is equal to minus 27 plus 27 by 2. So that is minus 27. So that means k is equal to minus 9. So that means putting the value in fx, in the expression of fx, we are getting fx to be equal to 4x cube plus x4 plus 2x cube, x4 plus 2x cube minus 9x square plus 9 since k equal to minus 9. So minus of 9x square plus 9. Well, so this is the entire expression of fx. Now we have to find the point value of m, that means at the value of global minimum of fx. So definitely that will occur at a point x where f dash x equal to 0. So once again let us calculate f dash x. This is 4x cube plus 6x square minus 18x, so that is 12x square, so that is by taking 2x common we will be getting 2x square plus 3x minus 9 is equal to 2x square plus 6x minus 3x minus 9. So if you factor it, you will be getting 2x minus 3 x plus 3. So definitely f dash x is equal to 0 imply any one of the factor is equal to 0. If the first factor is 0, that means x equal to 0. If the second one is 0, you will be getting x equal to 3 by 2. If the third one is 0, you will be getting x equal to minus 3. So whether you are considering local minimum or global minimum, they must occur at one of those places. So now let us calculate them one by one. When you are calculating the value of f at 0, it will be f0. So that means if you put the value of x equal to 0 here, you will be getting 9, f0 equal to 9. Similarly, if you calculate f of 3 by 2, you will be getting 9 by 16. And if you try to calculate the value of f of minus 3 by putting x equal to minus 3 in this expression, you will be getting the value of fx to be minus 45. So one of them must be representing the global minimum value. So which one is the smallest? Definitely this one. So this is the global minimum value m. Now you have been asked to find out the value of f0 minus m. Now what is f0? The value of f0 is 9, minus m means minus of minus 45. So that is 9 plus 45. Okay, so the answer is 54. So f0 minus m is equal to 54. Next question from 2023. Here it is asked to find point of discontinuity of certain function. What is the question? The question is given like that. Let box of t denote the greatest integer less equals to t. We'll talk about it. The number of point of discontinuity of the function fx is equal to box of x square minus 3x plus 2 for x between 0 and 4 is what? You have to find that. So first of all, what is box of t? What do you mean by that? As mentioned in the question, it is the greatest integer less equals to t. For example, if you take t to be 2.1, what will be the greatest integer less than t? Definitely 2. So box of 2.1 is equal to 2. Similarly, if you consider box of 2.5, that will be 2 as well. But if you reach at 3, box of 3 will turn to 3. So now, note carefully. When the value of t is bigger than or equal to 2 but less than 3, box of t will be equal to 2. When t is bigger than or equal to 3 but less than 4, the value of box is 3, and so on. When t is bigger than or equal to 1 less than 2, box of t will be 1, and so on, and so on. So box of t will be 0 when t is greater or equals to 0 less than 1. It will be negative 1 when t is greater or equals to negative 1 less than 0. So that's how box function will look like. So here you have to consider the box of the function x square minus 3x plus 2. So that is the function you have to deal with. So here you do not have to deal with the function x square minus 3x plus 2. Rather, you have to deal with the function box of x square minus 3x plus 2. And you have to say how many discontinuities are there of the function in between 0 and 4. Okay. So first of all, will note one thing, that the function we have to work with is box of the function gx, where gx is equal to x square minus 3x plus 2. You do not have to work with this function, you have to work with the box of it. And now you have to consider the value of x between 0 and 4. Now note one thing, what will be g dash x? If you take the first derivative, you will be getting 2x minus 3. And note that when the value of x is bigger than 3 by 2, this part will have value bigger than 0. So that is bigger than 0 if x is bigger than 3 by 2. Similarly, this part is less than 0 if x is less than 3 by 2. Right? So that means what? That means when x is bigger than 3 by 2, g dash x is positive, that means gx is increasing. And when x is less than 3 by 2, g dash x is negative, so gx is decreasing. So for x greater than 3 by 2, gx is increasing. For x less than 3 by 2, it is decreasing. So if we try to draw this, if this is 3 by 2, on the left of 3 by 2, it will come down like this. On the right, it will be increasing. So definitely the lowest value of the function g will occur at 3 by 2. Okay. So what is the value of the function at 3 by 2? G of 3 by 2 will be equal to, let us put the value x equal to 3 by 2 here. So that will be 3 by 2 square minus 3 into 3 by 2 plus 2, and that is equal to 9 by 4 minus 9 by 2 plus 2. So that is 4. 9 minus 18 plus 8. So that is minus 1 upon 4 is equal to minus 0.25. So at this point the value is minus 0.25. So what is the value at 0? So what is the value at 0? This is the expression. So if you put x equal to 0, you will be getting 2. And you have to consider function up to 4. What will be the value at 4? If you put x to be 4, then that will be 16 minus 3 into 4, 12 plus 2, that means 6. So here the value is 6. So that's how gx will look like. So let us draw it more clearly. This. So at 0, the value is 2. And if this is 3 by 2, then at 3 by 2, the value is minus 0.25. So that will come down up to this. And then after that, it will go up. It is increasing until it is reaching at 4, where the value is 6. So that's how G will look like. So that is the curve of G. Okay, so what do you supposed to find out? You have to find out box of gx, the number of point of discontinuities of box of gx, because gx is x square minus 3x plus 2, and you have been asked to find the number of point of discontinuities of the function box of gx. Okay, so let us look into the function g first carefully. So g starts with 2, the value starts with 2, it will come down to 1 at some point, then to 0, then lowest at minus 0.25, then it will go up once again, meet 0, and then 1, 2, 3, 4, 5 and 6. Now note carefully, the function will have the value box of gx. Now if you are considering, let us use this color to understand box of g. What will be the box of g at 0? G has the value 2 at 0, so definitely box of g will have the same value. Box of g will have the same value, but after that, after on the right of 0, it will drop at 1 till this, and then on the right of this point, it will drop to 0 until this point. On the right of this point, it will drop to negative 1, until this point. At this, it is once again at 0, 0 will continue, jump at 1, this, and so on. Finally, this. So that's how box of gx will look like. So that is the curve of box of g. Now let us count the number of discontinuities here. One discontinuity here, 1, and then 2, because this is the point where the second discontinuity will occur. Third discontinuity will occur at this point, 3, 4, 5, 6, 7, 8, 9 and 10. So the total number of point of discontinuities for box of gx is 10. So the answer is 10. Okay, so that's all. Thank you.